as I said, the rings were discovered before the Voyager spacecraft, but the Voyager verified that the ring system was there. The ring system was seen through this process that has been used by astronomers for a long time, long before we were able to send spacecraft to the planets. And what basically what happens is the when the planet from the Earth's point of view, okay, so as the Earth, of course, orbits the sun, the planet um, will block the light from a distant star. Now, of course, there's many stars in the sky, and so the planets are always blocking stars. But um, what we what happens, and by the way, this is called an occultation. What happens is when the planet passes in front of a particularly bright star, right? So one that is very bright, the ones that when you look up into the night sky you can see with the unaided eye. Those stars, the starlight passes, you know, passes behind the planet. The planet blocks the starlight, and and in during those times we that's when we first were able to see or detect the rings, because basically the light was blocked. There was like a dip in the light curve, and then of course the dip came from the planet. We know the size of the planet, so we know how long the dip should have occurred. But then the dip had occurred a little sooner and a little later than we expected, and people realized, hey, there's a ring system. Um, but like I said, it's mostly made from dust. In fact, what we're going to find out is some of the dust comes from one of the moons of Jupiter. All right, so there's lots and lots. All right, so let's start getting into the moons of Jupiter. All right, there are so yeah. Let me just start back in 1610. Going back to the time of Galileo, Galileo noticed that there were these four lights. I mean, that's his little telescope. You can only see that there were these four lights, and the four lights would change positions. Like, sometimes there'd be four of them on one side. There'd be two of them on the next night. There'd be two of them on one side, and then the other two would be on the other side. Sometimes you could only see three of them on different nights. And so what he realized correctly is that the moons were orbiting Jupiter, that these were moons just like the Earth has a moon. And they're now called, these are the four largest moons. And in fact, one of them, the one that's called Ganymede here, is the largest moon in the entire solar system. All right, so the four of them, Io, Europa. This is actually in order of distance from Jupiter. Io is the closer of the Galilean moons. Then comes Europa, which is a little smaller than our moon, and then Ganymede and Callisto. All right, so those are the four Galilean moons, and they've been studied time and time again. Certainly by the Galileo spacecraft, which took close-up pictures. I mean, that's how we have these pictures is from the Galileo spacecraft that orbited Jupiter for more than I think it was 2 decades actually. So close to 20 years. There are many satellites around Jupiter. This is a little older. I don't know when these PowerPoints were made, but there's closer to I think it's like 67 or 68, the last count. And there comes a point where the question is what is a moon? Um, there's such small little things going around Jupiter, that at some point you got to define something to be a moon. All right, the four large moons, the Galilean moons, are not they're not actually the closest moons. The Almathean moons are so there's a group of them. The largest one is called Almathea. Um, they are closer to Jupiter than I think there's, what is it, 4 or 5 of them. These Almathean moons. Uh, they're the innermost moons of Jupiter, and then all the rest of them are much smaller than these than these large moons. So as I was saying, Io. So let me just say a little bit about each one, and this information, of course, comes from originally the Galileo spacecraft, right? The Galileo spacecraft, which orbited Jupiter for a long time. All right, so spent time taking pictures of these. And of course, before that, remember, Voyager 1 and 2 flew by Jupiter in, I think it was 1980 or 1981, and took pictures. And one of the things that was actually discovered in 1981, I believe it was, when the Voyager spacecraft took pictures of Io. There was an engineer that was looking at the pictures, and she noticed that there was like a plume coming from Io, as she looked at these pictures that had been beamed back to Earth. And when she looked at the pictures, she saw this plume, and then she looked more carefully. She saw multiple plumes, and then other people verified this as well. And it turns out that Io, this object that we thought was a relatively dead world. It's about the size of our moon, so we didn't think there'd be active geology on Io, but it turns out to be the most volcanically active object in the entire solar system. There's volcanoes going, there's at least a dozen volcanoes or more, depending on the time that you go and look, going off at any given time. So there's volcanic activity, and one of the results of the volcanic activity is there's sulfur that escapes Io and will travel around Jupiter, and that's the dust. That's part of the dust that makes up these rings of Jupiter. Is the sulfur that comes from Io. All right, the next moon, the smallest of the Galilean moons. Remember, this is just the 4 largest moons that was originally discovered by Galileo in 1610. He only saw them as little specks of light, but correctly, determined that they were moons. Europa, and these are actually the names that Galileo gave them. Europa is a very smooth looking moon. It has a relatively young surface, and remember, young surface means there are very few craters on Europa. So there must be something that is causing Europa to resurface itself, or resurface. Well, it resurfaces itself, and Europa, as we're going to find out, is one of the candidates for finding life outside of the Earth. Life, living things in we think that there's really strong evidence over the many years that we've been studying Europa that there are a giant liquid ocean underneath the surface of Europa, and the surface of it looks like um, ice. It looks like cracked ice. It's cracked in certain areas, um, but it's a relatively young surface. And just to let you know, the amount of water, right? So this is something. So Europa is smaller than our moon, little bit smaller than our moon, but the amount of water that is on that is believed to be in the oceans of or the ocean, the subterranean ocean of Europa, is more liquid water than is in all the oceans of the earth combined. Like, you combine all the oceans of the earth, there's more water in Europa. All right, so then we turn to the largest moon in the entire solar system, Ganymede. Ganymede is cratered, not heavily cratered. Um, I mean, somewhat cratered, but there's evidence that Ganymede has something that's causing its surface to be redrawn. Um, and actually, we think that there's a possible liquid ocean underneath Ganymede as well. Um, and then we come to Callisto. All right, Callisto is the furthest one from. Well, I mean, there's moons that are further away than Callisto, but it's of the four Galilean moons. Io is closest, then Europa, then Ganymede, and then Callisto. You'll have, if you had this lab already. We have a whole lab on using the Galilean moons to determine the mass of Jupiter, right? So, at any rate, so if you look at Callisto, Callisto is the one of the most heavily cratered objects in the solar system, right? So it is incredibly cratered, and so it looks like, stuff has been hitting it, really since the creation of the solar system 4.5 billion years ago. So this is a very, very heavily cratered object. It doesn't look like that. There's nothing that's changing the surface of Callisto, other than collisions, right? Lots and lots and lots of collisions over 4.5 billion years. All right, so they're all very large moons, or they're larger than our. All four of them are larger than our. I'm sorry, all all except for Europa is larger than our moon. Europa is just slightly smaller than our moon. Um, let's see, process of formation. So they're basically like little mini solar systems going around Jupiter. Um, and Oh yeah, and so the density of Io is the greatest, and then it gets progressively less dense when you get to Callisto. So the more dense stuff is closer to Jupiter, the less dense stuff is further from Jupiter. So this was one of those plumes. This is actually taken from the Galileo spacecraft. This is a really good looking plume. The original one from from the 1980s, taken by the Voyager spacecraft, was not a very good looking picture at all. But we were able to determine that there were active volcanoes on Io. Now Io it's too small to have active volcanoes. Nobody expected this, and like I said, it was a complete surprise. And so, what is it that's causing um, the volcanoes, and so many of them going off so often, that just a simple flyby in the 1980s showed volcanic activity. And by the way, there's There's indications of lava on